All right, what is up, you guys? Welcome to another video on prime logic. Today's problem is especially interesting because it taps into your spatial reasoning and deep geometric understanding. So if you want to solve this problem, please pause the video because I'm going to solve this problem right now. So the problem setup is pretty much simple. We have a quarter circle, we have another circle inside, and we have this tangent line, which is 12 units. And our mission, our job is to find out and to calculate the area of this shaded region. So basically that's the area of this quarter circle minus the area of the circle. So the first approach that I'm going to give you is kind of very, very highly intuitive because there is no messy kind of algebra, not a lot of, no calculations at all. So just imagine what happens, what if this inner circle approaches to zero. It becomes smaller and smaller and smaller. So imagine we have a setup that the tangent line is here and this kind of inner circle is infinitely small. It's so small that it is basically zero, right? So if it approaches to zero, the tangent line approaches to the radius of this quarter circle, the bigger one. So imagine it becomes smaller and smaller and smaller. So basically, and infinitely, it becomes the radius of this quarter circle. So you can now just simply say that the area of the shaded region equals to the area of a quarter circle with a radius of this tangent line, with a radius of 12. So we can say that area of the shaded region is pi tangent line, so which is 12 pi r squared over 4. So it becomes 144 over 4, that's 36. So 36 pi, sorry. So that's the answer, 36 pi. And the shaded area, it always remains the same, stays the same, no matter how big or small this inner circle is. It is always in this setup, so when the tangent line is just 12 units, it is always 36 units. So that was very intuitive, very reliant on your deepest understanding, spatial reasoning, understanding, etc. So the second approach is more like into calculations, normal, traditional, conventional geometric calculations. So let's name, for example, the radius of the smaller circle as little r, and this radius of the bigger circle as just big R. So what we want to do, the area is, so the area of this quarter circle, which is pi r squared over 4, right? That's the area of this quarter circle minus the area of the circle, which is pi little r squared. So let's put a box around it now. So let's do some basic geometric calculations now. So we know that this length is also the diameter of this small circle, which is 2r. And we know this tangent line is 12. So let's draw a line here, kind of here. So it doesn't have to pass through this center. So for those of you who are interested, if it must pass through the center of this small circle, no, this is just coincidence, or this event didn't pass, but I mean, this circle could be way bigger, way smaller, so it is just irrelevant. So let's try this Pythagorean theorem now here. So we know that this is a right angle triangle, right? So this length is r, this big R. So we know we can write that r squared equals 12 squared, 144 plus 2 little r squared. So squared, which becomes 4r squared. So let's bring this 4r squared to the other side. So r squared minus 4 little r squared equals 144. So let's divide all sides by 4. We can say that, so r squared over 4 minus 4r for little r squared over 4 equals 144 over 4, which is 36, right? So they two cancel out. Let's also multiply all terms by a pi. So pi big R squared over 4. So let me delete this part. Minus pi little r squared equals 36. And we had the area of this shaded region as, and that was the first relationship, right? So pi big R squared over 4 minus pi little r squared, it is the area of the shaded region, and this is the same thing here. So pi big R squared over 4 minus pi r little r squared equals, oh sorry, I forgot to multiply this term by pi as well. So it equals 36 pi. So that's the same thing that we found here. So kind of that's a generalization. So you can write it down as a generalization as well. So I have a question for you. Is it possible, so based on your understanding, is it possible to find out, so if you have just a tangent line, is it possible to find out the radius of either of these circles, either this bigger circle, quarter circle, or this inner circle, or no, that's totally, utterly impossible. So I think that's going to wrap it up for today, guys. I hope you really did enjoy today's video. I want you, so obviously that's not the only approach. I want you to comment down your solutions and approaches and your ideas as well. And make sure to subscribe, like, and share if you haven't already for more problems like this. And as always, I love you guys, appreciate you guys, and see you on our next video. Prime Logic signing out.